Welcome back to Applied Algebra and Trigonometry. We're going to be talking about graphing the rectangular form of complex numbers. While graphing complex numbers in their rectangular form, we let what we would usually call the x-axis indicate the real part of the complex number, and what is usually the y-axis will indicate the imaginary part. So let's take a look at a few numbers and how they would be graphed. We'll let A represent this complex number, 3 plus 4j. And to graph that, we would go 3 in the real direction and up 4, because it's a positive 4, in the imaginary direction. And then we would draw an arrow from the origin to that point. So that will represent the complex number A, 3 plus 4j. Notice I did not put an arrow above the j in either place. These are not vectors. This is a representation of complex numbers. It's very similar, but not exactly the same. So now let's graph the complex number that we will represent as b. It is the number negative 3 plus 2j. So we will go negative 3 in the real direction and positive 2 in the imaginary direction, and draw an arrow from the origin to that position. So there is B. And we could do C. Let's let C be negative 1 minus 3j. So we would go negative 1 in the real direction and negative 3 in the imaginary direction, and draw our arrow. We can also use this coordinate system to indicate addition and subtraction of complex numbers. So let's add a couple of these numbers. Let's add A and B. So we have 3 plus 4j. To that, we're going to add a negative 3 plus 2j with the method that we talked about in the previous video. That would give us 0. Okay, the 3 minus 3 gives us 0 in the real direction, but we would have a 6j. And where would that be? That would be right on the imaginary axis. 3, 4, 5, 6. So there is 6j. We could let that be represented by D and an arrow from the origin to 6j. And if you notice, look at what we have here. If we complete the parallelogram, it looks a lot like adding vectors, doesn't it? So you could add complex numbers graphically. But what if instead of adding A and B, what if we subtracted B from A? What would we get? We could call that number E. So we would write that as 3 plus 4j minus the entire complex number of B, negative 3 plus 2j. That means we need some more room here. Okay, because I'm going to have to rewrite this in order to go ahead and add it. Or I guess I could have just erased everything, but this way you can see what I'm doing here and how B is changing, because that negative has to be distributed to each part of B, the real and the imaginary. And that will give us 3 minus 2j for a sum of 6 plus 2j. And let's move that over, because now we can move back and see the graph. We're no longer adding b, we're adding negative b. So we need to go over 3 and down 2. And that will be here. So now we're adding a and negative b, and our answer is 6 plus 2j, which is the opposite corner of this parallelogram that we can draw. All right, one more addition and one more subtraction, and we'll call it a video. I will not be showing you how to multiply complex numbers and graph them, because for each complex number we already need 2 dimensions. So to multiply two complex numbers, we would need 4 dimensions, and that is beyond my drawing ability. So let's say we want to add the complex number 3 to the complex number negative 2j. Remember, the other parts of each of those just has a value of 0. So we could say 3 plus 0j, and we could say 0 minus 2j. Those are complex numbers. Let's graph them. A would be 3 in the real direction. Okay, real and imaginary. So our arrow would be right along the real axis over to positive 3. Our B is a negative 2 in the imaginary direction. Give you this complex number to which the arrow is pointing. And that would be 3 in the real direction and minus 2 in the imaginary direction, which is what we get if we add those two complex numbers. All right, but let's look at what happens if instead of adding, we go back and we subtract. But just to mix it up, let's subtract A instead. So our B would still be a negative 2j. Our A, though, will now become a negative 3. And when we add those two, let's see, this would become, let's say, D. D would be negative 3, negative 2j. So how would we graph that? Our B would still be here, the negative 2j. There's the B. Our A would become negative. So this was our original A. Here's our new A negative 3. So we have B minus A. You could represent that with an A prime if you wished. And when we finish the parallelogram, we would have our difference, negative 3 minus 2j, number D. That sounds weird, but remember D just represents the complex number, negative 3 minus 2j. That's all of the graphing I have for you. I told you this was a rather easy section, so I'm sure that you will do fine covering both basic operations with complex numbers and graphing complex numbers and their operations in one day. You can handle it. And we will talk about it in our next Collaborate session. See you there.